Yeah, it's done, sir.
Okay, great. Thank you. Okay. So let me quickly summarize what we had done in the last class so that we can go ahead and do this one. So go back. So in the last class, we actually started to look at the different data types that are there in Python. Okay? And within that scenario, we looked at, we summarized Booleans and numbers, and we started to look at strings. Within strings, we saw, let me go ahead. We saw how to create a string, how to access the elements of a string. We also saw how to access the elements counting front and counting backwards, counting forwards and backwards. We saw how to use a for loop with a string so that we can traverse the elements of a string together. We also saw how to grab slices from a string. So it uses the same concept as range to help us to grab different slices from a string. Okay. We could do that forward, backwards. We could also do that by keeping some of the default values as blank. Okay. So when we leave it as blank, we know if you leave the start value as blank, it calculates as 0. When you leave the end value as blank, it calculates the last character. And if you leave the step blank, the step is always 1. Okay. Unless we want to change something. Just go ahead. Then we have lists. List is basically the data structure that can hold an ordered collection. We also saw that lists are mutable in nature. Okay. So since they can hold an ordered structure, we saw how to add integers to a list, floats to a list, strings to a list, and then we saw that lists can also contain multiple data types within the same list. We saw how to access elements of the list, how when we go outside the list, we will get an index error. And we can use the same concept that we used in strings, that is to access the elements backwards. We saw how to create an empty list, and we saw the concept of shallow copy and deep copy, which basically is that deep copy comes with a different memory element, and shallow copy comes with the same memory element. So when you update the value of shallow copy, the original copy also gets updated. Whereas when you update the copy in the deep copy, the original copy does not get updated. Then we saw how to compare different strings. So we saw that, okay, we can compare individual characters. We can also compare the whole string together, and we can try. So this was something pointless. We could just see the first value is big or not, and we can do that. Okay. Then we saw that list is actually, or any data type per se in Python is actually a class method. And when we say that it is a class method, then we mean that operators may not work as we would normally expect. Operators may be modified as per the definition of the class. And also the operators may be modified as per the definition of the class. And also we may have certain additional functions that we can use along with the class. Okay. So here we saw examples of creating multiple lists. When we add the list, we don't get mathematical addition. In fact, we get something called as joining. Okay. And the joining of the string is also called, like joining of the list is also called concatenation. We also saw that when we multiply a list, instead of multiplying the elements of the list gets duplicated as many number of times. Okay. We saw the length function that helps us to find what is the length of the string. Going ahead, we saw certain more instructions or functions that can help us to add elements into the list. So 3 cases we saw of append, extend, and insert. Append will add items to the end of the list. So any item that you add will be added as one object. Even if you add a list, that list comes as an additional list at the end. We saw the extend function, which is able to extend two lists. So it will take one list, take this copy of the second list, and add all the elements together. So someone says, what is the program you said? It's Google Colab, COLAB, Google Colab. Let's go ahead. We also saw the insert function. So append function or extend function is able to add things to the end, whereas the insert function can add things anywhere in between. So you have to specify in the first operand, you have to specify in the first argument, you have to specify the location where you want to add. In the second argument, you have to specify the value that you want to add. Okay. Then we have the delete method, or the ways to remove elements out of the list. We can use the DEL, the pop method, or the remove method. The DEL method you can use to delete individual elements or the entire list. We can use the pop method to remove the last value. So pop without any argument, pop removes the last value, and the last value will be popped out into the variable X. And the original list will be updated. That is, the original list will lose the last value. That is what happens when we use the pop without any argument. But when you use an argument in pop, pop will remove the value at this particular index. So it will pop the value at that particular index, and the original value will get updated. The remove function is able to remove the value that you want to remove. So pop and pop2 and even delete, they uses the location, whereas remove uses the value that you want to remove. Okay. So when you try to remove something that is not there within the list, it will give you a value error saying that this item is not in the list. I think this is where we had stopped last time. Let's continue with looking at some more functions of lists, and then we will proceed with other parts of the other data types within Python as well. Okay, so a few interesting functions that are present with list is max, min, sum, count, and index. Okay, so let's say for an example, we will start with this sample code, where we say that list L1 has these values of 4, 8, 6, 7, 8, and 9. And when we write something like max of L1, what it does is it goes to this list and it says, what is the maximum value? Whatever is the maximum value will be copied into this variable that we are capturing. So in this case, we are capturing it into max number. So we can see the maximum value is 9. Similar to this, we have the minimum function to give us 4. We have the sum function that adds individual elements together. So when you add 4 plus 8 plus 6 plus 7 plus 8 plus 9, you end up with 42. We have a count function, which counts the number of times a particular element has occurred within the list. Okay, so here we say if we do count 8, you see there are 2 instances of 8. So it is able to count how many times we have 8. So it gives us, okay, L1.count 8 gives me 2. Further, we can also find the index of an element. Okay, so here the index of the elements are 0, 1, 2, 3, 4, and 5. Okay, so these are the index of the elements. When we do something like this, when we say L1.index 8, it tells us, it goes to the list and says, where do I find 8? Okay, what is the first value that I find 8? So 8, not here, it's here, right? So it says, okay, it has found 8, so it returns this index value as 1. Okay, but you see, in our case, in this case, we have multiple values of 8. We have 8 at the index 1, we have 8 at index 4 as well. Okay. So we can also specify to the index function, where do I want to search? So in this case, I'm passing 3 arguments to the index function. The first argument is, what do I want to search? So I want to search the value of 8. Second is, from where, starting from where to where. So we're starting from 2 till 5. We are trying to search the value of 8. Okay, so let me go here. So when you search from 2 to 5, the value of 8 you get at the index 4. So it is able to return to us index 4. Okay, so all these are very basic functions: max, min, sum, count, index. Even if we did not have this function, you could have easily written a simple piece of code to be able to get this. The thing is, with Python, generally, if you are writing, so as a thumb rule, maybe this is not always true, but as a thumb rule, if you're writing too much code, probably you should search and find that there may be a solution where you may have an inbuilt function, or you may have an inbuilt package that can help you get your task done. Okay. So someone is saying, sir, if we write 1 to 5, okay, instead of here, if you had written 1 to 5, you would have gotten the first value. Okay. You would have gotten this value as index. So index returns to us the first occurrence of its match. Let me go ahead. Then there are additional functions like sort, sorted, or reverse. Okay. So let's look at those examples. In this case, we are starting a function L1 with the values 5, 2, 4, 9, 7. And when we say sorted of L1s, when we say sorted of L1, it is able to sort these values in the ascending order. So it says 2, 4, 5, 7, 9, and that's it. We have taken L1, we have sorted it, and we have captured it into another list L2. Okay. So we see that L2 has a sorted list of L1, but L1 is not updated. L1 stays the same. Okay. L1 stays the same. If you want to directly change L1, so in this case, what you could have done is, if you want to update L1 directly, we could have written L1 is equal to sorted L1. And that is one way of doing things. But an easier way of doing things is something like this. We use the L1's dot sort function. Okay. So what do I mean is L1 is the object of the class list, and the class list has an inbuilt function called as sort. So in that case, you don't have to pass it as an argument. You can directly write L1 dot sort, and this directly sorts L1. Okay. So we can see L1 gets sorted here, 2, 4, 5, 7, 9. So what if you want to have it in the descending order? Okay. In this case, we have it in the ascending order. What if you want to have it in the descending order? In that case, to the sort function, you provide an argument, reverse is equal to true. Okay. And when you write reverse is equal to true, the sort function sorts the values in the descending order. So the highest first, followed by the next highest, and so on. And in the end, you have the lowest, or the one with the minimum value. So that is your dot sort function. We also have a dot reverse function. And here we are passing arguments 77, 55, 88, 11. And then we have dot reverse function, which just reverses the values. Okay. So we take the last value, put it as 11, second last, put it as 88, third last as 55, fourth last as 77. Okay. So it just reverses. So it has nothing to do with the sorting of the values or the reverse sorting. It is just shifting, putting the first element as the last element as the first, and keeping that order. So someone asked the question, what is the difference between sort and sorted? Okay, so sorted is a generic function that can take different inputs. Sort is a class method. So L1 is an object of the class list, and that list has a method called as sort. So in this case, this sort is specially defined for lists. Okay, this sort may not be specially defined for lists. So either ways, you can use either one of them. If you just want to take the copy of L1 and sort it and store it into some other variable, then you cannot do it with sort. You have to do it only with sorted. But if you want to do something like this, then you can do it here. So that's the difference. Let me ask you a question. We saw the dot reverse function that is able to reverse the order of the code. But if you remember, while accessing slices using lists, we could also write some simple piece of code that would reverse the elements of the list. Can you write that code on the chat box? What simple code could you write with slices? So when I say slices, I mean something of this form. What values could we put so that we get the reverse of the list? Okay, someone says -1. Okay, where should I put -1? Okay, excellent. Now I got the right answer. Colon, -1 will reverse the list. That is excellent. Okay, so let me go ahead. Further, we can check list membership operations. That helps us to know if something is in a list or not. So we have already seen the in operator. Like if we write L1 as this list, having the values, if we write L1 as this list, having the values 2, 3, 4, 5, having the values 2, 3, 4, 5, And if we write for I in L1, the in operator is able to access individual elements of this list L1 so that we can print it using a for loop. Okay. We saw that the same idea held true when we were accessing the elements of a string. But here also, for lists also, when you write for I in L1, you are able to access individual elements of the string one at a time within a for loop. So when you write print I, you can print the first element, second element, third and fourth consecutively. Okay. You can also use the in operator to check if a variable exists within the list or not. So in this case, we have the list with 2, 3, 4, 5. We have created a new variable x with the value 4, and we are asking the question if x in L1. Okay. So when we write if x in L1, the code will simply verify if this value 4 exists within the list L1, and if it exists, this condition will become true. And we know how if works. If this condition is true, we will enter in this part of the code, which says print x is a member of element L1. Okay, so we can write x is 4 is a member of element element of L1. So L1 is the list here 2, 3, 4, 5. Okay, if the condition was not right, then we would have entered into the false condition. We can also have something called as nested lists. So nested lists are basically where we have lists as elements of an outer list. Okay, so let's see this example. So here we have a list X which has two elements, element 1, element 2. Element 1 is in fact a list and it has three elements, element 1, 2, 3. And element 2 of the outer list is also an element with three elements, 3, 2, 5. Okay. So what I mean by that, let's look how we can access these elements using a for loop. So I can write a nested for loop, the first for loop to access the elements of the outer list, and then an inner for loop to access the elements of the inner list. Okay. So let's see here, when I write for I in X, I will take two values. In the first case, it takes this value. That is what we print here. That is, we print 2, 4, and 6, which is the first value of X. So let me write first value of X. What I mean is X0. Then we write for J in I. So I has three elements. So this is, okay, I has three elements. So this will be accessed as, okay, this will be accessed as X0, 0. That is accessing the first element of the zeroth element. Okay. Then we have accessing X01 and finally X02. So we see the outer loop here. This loop is controlled by I. So I will take the values 0 and 1. And these values are controlled by J, which will take the values 0, 1, and 2. So when you write the inner loop for J in I, print J, it prints 2, 4, and 6. Okay. Similarly, in the next iteration, I will take this value, which is 3 to 5, which will be X of 1. And then J will take values within that list, that is 3, 2, and 5, which will be X of 1, 0, 1, 1, and 1, 2. Okay. Let me make this a bit more clearer by this example. In this example, we have the list Y, okay, and the list Y has how many elements? So let me see. So I see list Y as this as one element, and this as second element. Okay, so list Y has two elements, element 1, element 2. Now element 1 is actually a list of three elements, element 1, element 2, element 3, and element 2 is a list of two elements, element 1, element 2. Further on, we can see that this element and this element also has 3 values each. Okay, and this element has 2 values each. Okay, so this is what our Y looks like. Now, how can we access elements of a nested list? So when I write, so I've already explained here. When I write X of 0, I go to the first element, and within that element, if I write 2, we go to index 0, index 1, index 2. We are able to access this value 6. In this code, what we are doing is we are updating that value 6 with the number 66. So when we write 0 to X0 to 66, we see that the original value of 6 here has now updated to this new value of 66. Okay, let's look at this example where we write y 0 to 0 as 66. So what is 0 to 0? So y 0th element. So this is the 0th element of 5. Then the second element, which is 0, 1, 2. Second element is this element, and its 0th element means this element. So we are updating this value of 6 by the new value 66. And you can confirm that this value 6 gets updated to the value 66. Okay. So let me ask you a question. How can I update this value 5 with the value 55? What should I write so that this number can be updated to 55? Can you write that in the comment box? Oh, so no one has answered yet. So my question is, if I want to update this value of 5 as 55, what values should I enter here? Okay, so I've got multiple answers. 1, 2, 2. Okay, so let me tell you what the right answer is. So we have to go to first this element, the second part. So this is element 0, this is element 1. So this has to be 1 here. Within element 1, we have to go to this is element 0, this is element 1. We have to again enter 1 here. Okay. And now within this element, we have to go to element 1 here. So when you write y111, you have now reached this location. And to this location, you can update the value as 55. Okay. So many of you got it right. Excellent. Good job. Let's go ahead. Further, we looked at strings. There are two interesting functions with string that can help us. Okay. So we have a function called a split, and we have a function called a join. So let me first explain the split method, and then I'll explain the join method. So if we have a string, which is specifically like a statement like this. Okay. So we have a statement. This is sample string example. Okay, and there are words, and these words are separated by these spaces. Okay, so I can call the split function, which tells me what is the separator and how many maximum split do I want. Okay, what is the separator and what is the maximum split do I want? So when you write something like this, so we see s as having this string. When I write s dot split, by default, the split separator is defined as a spacebar. Okay, so this is defined as a spacebar, and the maximum split is infinite. Okay, so you can go as many splits as possible. So those are the default values. So when we take the string s, and to this s we do a dot split. So just remember again, doing a dot split means that s is a string, and this string element has an interior class method called a split. And when we do a dot split, we are able to split this string based on these spaces. So what it does, it returns to us a list, and this list is having elements which are basically words or strings within the big string, and this big string is separated using spacebars. Okay. So we get the first word, it comes as the first element here. This word becomes is sample string example. So all the spaces are gone, and we are left with a list of strings. Okay. Someone is asking, split can create string into list. You could say that, but we need to specify the separator. Okay. So in this case, since the separator is a spacebar, it separates the string into lists using these spaces. So this is the default implementation. In the next case, what we are doing is we are passing two arguments. The first argument is what is the separator we want. Second is how many splits we want. Okay. Okay, I don't understand the question, which is same data type only. Okay, so here when we write spacebar and 2, we will split using the spacebar, but we will split only 2 times. So when we split for the first time, we get this as one element. When we split for the second time, we get is as another element, and then everything else goes into the third value. Okay, everything else goes into the third value. So here we can define how many times you want to split. Let's take another example. So this is a string where I have numbers 10, 20, 30, 40, which are separated using commas. I can specify the separator as comma to split these into individual strings. Okay. So when you say s1 dot split with the separator being a comma, what happens is you get the first value 10 here, then 20, 30, 40 as different strings, and it returns to us a list of these strings. Okay. Let me go ahead. In contrast to that, we saw split is able to split a list of strings, split a string into a list of strings, whereas we have the join method, which is able to join a list of strings together into one string. Okay, so how does this work out? In this case, let's say we have L1 as our example, which is a list. It is having strings. This is sample string example. And when I want to join it, I can write this. I can write in inverted, in double quotes or single quotes, I can write a string. So in this case, this is just a space bar. Okay, so that is why we have a space between these two values. So when we give a space bar and we do dot join L1, what it does, it takes this as the joining element and it joins the different items or the different strings available in the list. So here we get the first element here, this, and then with this joined element, which is a space, we take the next element and add it here, a space, the next element and add it here, and so on. So what we end up is, we end up with this value joined with space bars. So it is not necessary to join with space bars. We can use any kind of value. So here, if we use a hyphen, we can see that this value gets joined using these hyphens. So now for S, this iterable need not just be a list. It can be a tuple, it can be a string, it can be a dictionary, or it can be a set. But the most common implementation is a list. Okay. Nonetheless, let me go ahead. Then we have something called as list comprehension, which I believe is very, very, very powerful. So let me show you an example of what I mean, and then how we can do it using list comprehension. Okay. So let's look at this part of the code. But the task is very simple. We have a list called as numbers. It has the values 1, 2, 3, 4. And we are creating a list called as squares. And what we want is, we want to populate this list squares with the squares of these individual numbers. Okay. So these individual numbers are 1, 2, 3, 4. We want to populate this so that it becomes 1, 4, 9, and 16. That is, we take the square of individual elements and we add it here. Okay, that is our task. So to do this simple task, what we can do, okay, let me just second. Okay. To do this simple task, we can write a for loop and we can say for n in numbers. So what it will do is, n will take different values of the elements of numbers. Numbers, so it will take 1, 2, 3, 4. So n will take different values. Okay. Then we take the squares object and we say squares dot append n star star 2. Okay. So do you remember what the star star operator does? Okay. So this star star operator, it will do power. Excellent, you're right. So we'll say n square. So that is what we want. We wanted n square, so we are adding n square. What we're doing along with n square is we are appending with this value. So we started off with an empty set, and then we are appending, or we are adding elements to this list. And the element that we are adding is basically n square. So what we end up is, n will take different values. For each value, we will take its square and we'll add it to this value. That is what we're getting here, 1, 4, 9, 16. And then you print squares, so you can see that we have printed the answer. So excellent. So this is a simple way, a very simple code for getting the squares. Okay. Now the interesting thing is with Python, okay, maybe I can comment on one more idea. Someone, when we were explaining empty list, someone had asked, what is the purpose of this empty list? Can you see a purpose of the empty list here? We are using square as a placeholder. We started out with empty, and then in the for loop, we are adding elements to the square. So this is generally the need of an empty list. Okay, coming to the main point, we can do the same thing or the same answer with something much simpler. It is called as list comprehension. Okay, so what list comprehension does, let me explain the syntax. It says I can create a new list, okay, by doing some operation here. So the operation here looks like this. We know that this variable will be a list because whatever operation we are doing, we are capturing that into square brackets. So if you create a variable with square brackets, we know that this has got to be a list. Okay. So what will be the elements of this list? Okay. So it says the element of this list will be of this type, expression. Whatever expression gives us will be the element of this list. Okay. Now, what is expression? So expression comes from this for loop. So we will either run a loop with one or more conditions, and the result of those conditions will be captured here in the expression, and this expression will be the kind of elements that we'll be adding to the list. Okay, so I know at this point it is very complicated. Let me go to this example that will make things clear. Okay, so here same task, we have the variable numbers. We have the variable numbers, which is a list of items, list of integers, and we want to populate squares, which we want to be a list, which will be the squares of these elements. So here we are using list comprehension. So here saying this list squares should be populated with these kind of expressions. What is the expression? N square. We want to populate it with N square. But what is N? So it says, okay, let's go ahead. N is basically for N in numbers. Okay, so if what is N? N are the individual elements of this list numbers, and we are running a for loop into it. So what we get is the same thing that we did here. For N in numbers, we see for N in numbers, and instead of squares.append, we can write simply the expression N square. And what it does, it gives us these values 1 square, 2 square, 3 square, and 4 square within the variable squares. Okay. Fine. Let me ask you a question then. Okay. So let's say if I want to say create a list called as doubles, and what I want is in my final answer in doubles, I want to store the value 2, 4, 6, and 8, which is basically the multiplication of these guys. Okay, multiplication of these guys with 2. And if I want to do it with list comprehension, can you write the code for it? What code should I write so that we get the double values within the list double? Okay, excellent. So many of you have written it rightly. It will be N asterisk 2 for N in numbers. Okay, that's right. Let me go ahead. Going ahead, we can use list comprehension with complicated criteria also. Okay, so let's look at this case. In this case, we have a list A with the values 1, 2, 3, 4. We have a list B with values 2, 3, 4, 5. And what we want is, we want to create a list called as common num, which should have the common values between list A and list B. Okay, so the common values between list A and list B is 2, 3, 4 and 2, 3, 4. Okay. Okay, someone is saying what is the predefined function for square? So as far as I know, within base Python, I don't have a predefined function for square. Okay, if I want to do square of a list, there is an easier method, but let us finish these classes, and when we go to a package called as NumPy, then we will look at how to do it easily. Someone is saying append will add the last number. No, append will not add the last number. Append will add a number to the last of a list. Okay, so if I have a list L1 with, let's say here, and I do L1 dot append as 5, this 5 will get updated here. So L1 will become 5. But now if I do L1 dot append as 4, where should this fourth element go? So it will become, instead, it will not go before 5, it will come after 5, 5 comma 4. Okay. So append will always add list to the end of the list, end of the existing list. Okay, let's look at this example where we want to find the common numbers. The common numbers are 2, 3, 4, 2, 3, 4. So we write a list comprehension method which goes like this. We are saying, so we know that the answer is going to be a list because we start with a square bracket, we end with a square bracket. Now what will be the elements of this list? The elements of this list will be the type A. Okay, whatever we find in A will be the elements of the list. So the question is, what is A? So A comes from this part which says for A in list A. So A will take all the elements of list A, but we have an additional condition. The condition is if A in list B. That is, if this A will take each values of this list A1, list A, and if this value of A is also there in list B, only then this value of A will be returned. Okay. So what ends up happening is you get the common elements. Let's say you go to the first element 1. So A has the value 1. Is A in list B? Is 1 in list B? So we say no, it is not in list B. So it does not get returned. Okay. We go to the next value 2. So is 2 in list B? Yes, 2 is in list B. So it gets returned here. So we get the first element here. 3, is 3 in list B? Yes. Is 4 in list B? Yes. And then the loop ends. So we stop here. Okay. So thus we get the common elements of list A and list B, which is 2, 3, and 4. Okay. Let's look at this part where we are trying to combine different numbers from two given lists. We have a list A with values 1, 2, 3. We have a list B with values 2 and 7. And what we want is, we want to combine these elements together. And when we want to combine these elements, we just have to ensure one criteria, that both elements should not be the same. So here we combine 1 and 2. See, 1 and 2, this is the answer here. We combine 1 and 7, which is fine. 2 and 2 we will not combine because both are same. We want both these numbers to be different. We can combine 2 and 7, which we got here. We can combine 3 and 2, which we got here. And then we can combine 3 and 7, which we got here. Okay, so that is what we want to return. You may notice here that we have a different kind of notation. We have this additional parentheses. Okay, I will explain to you what this is in the next slide. This is basically tuples. Okay, but I'll go more in detail in the next slide. So to get this combination, when we write the code different num, we first return. We start in square brackets and end bracket. So knowing that this is a list, we are saying return the expression of these types. Okay, in a tuple, you return A, comma B. So we know this will be the type that will be the elements of the list, different num. But what is A and what is B? For which we write this part of the code. It says A is basically for A in list A. So A will take the elements of list A. What is B? For B in list B. So B will take the elements of list B. And we are adding a condition which is saying that only return these values when A is not equal to B. Okay, so we will not get these equal combinations. We will get everything else. And that is what we end up getting here. We get 1, 2, 1, 7, 2, 7, 3, 2, and 3, 7. Okay. Someone asked the question, how to print uncommon numbers. So let me go to this example. And here you're saying how to print uncommon numbers. Okay. So in this case, we would want to say return A if A is not in B. Okay, but we will not end up with this part. So getting uncommon numbers with this kind of list comprehension, I think will be more complicated than doing the normal program. Okay, one way of getting uncommon numbers is I find the common numbers and then I create. So just wait for a few more slides. I will introduce to you a concept called as sets, and using sets we can find the uncommon numbers very easily. Okay, just hold for a few more slides, and you will get an easier way of getting this thing done. So the task here is not just finding common. So to get the common numbers between these two lists, this is not the best method. This is just a demonstration for the list comprehension method. The best method to get the common numbers between these two guys would be using sets, and I will show you what those are. Okay. For now, I hope you have understood list comprehension. I'll go next to the next data type, which is a tuple. Okay. And if you remember, initially when we talked about tuple, I said that there are two kinds of data types within Python: mutable and immutable. And for immutable, I only told you two examples. So one was strings, the other one is tuples. Okay, so tuples are immutable items. Immutable items means once you create them, you cannot update them, you cannot add to them, you cannot change them. Okay, they are immutable in nature. Whereas mutable items are lists, sets, dictionaries. That is, once you have created them, you can add more values to them. Okay, let me go ahead. Tuples are used to hold multiple objects. Think of them similar to lists, but without extensive functionality the list class gives you. Okay, so we have got a limited functionality, but you can imagine them to be similar to lists. Okay, one major feature is that they're immutable, means that you cannot modify the tuples. And tuples are usually used in cases where a statement or user-defined function can safely assume that the collection of values will not change. So tuples are used for tasks when we want to have a list of items which will not change. In those cases, we will use a tuple. Okay. Let me show you some examples of how to create a tuple. So in this case, we are writing the variable t1 and we are starting this with an open parenthesis and close parenthesis. See, for list, we have to do open square bracket, close square bracket. Whereas for tuples, we have to do open parenthesis, close parenthesis. These are the same parentheses that one uses for a function. Okay. But here you have to remember, since there is no function name and there's a space here, we know that this open and close bracket, they do not correspond to a function. Okay. So here we write open parenthesis, close parenthesis, and within this part, we write the elements that we want to add in the list, and we separate them using commas. Okay. So when you say print t1, we can see that t1 gets printed like a tuple. And when we print the type of t1, we can clearly see that it is an object of the class tuple. So this is how we created t1. Let us create another tuple t2. We say t2 is 5, 4, 2, 6, 7. And you see the difference between this one and this one. We can also create a tuple without putting the parentheses. Okay. Even when you don't put the parentheses and you just write multiple numbers separated by commas, Python automatically understands that this is the type, you have to create a tuple out of it. Okay. But I would recommend, do not use this method, use this method. It is better to be clear rather than being unclear. Okay, so this clearly knows that we are doing a tuple. And here it may be difficult for someone who is not from Python to understand what you're doing. Now we can have a tuple with single element, but to do this we have to do an interesting thing here. Okay, so let's say we are starting to write a tuple and we want only one value 5. You write it, since you want it in the tuple format, you write it in open parentheses, close parentheses, you put the single value. You expect that x1 is tuple, but when you print x1, you see that it is not printing this brackets. That gives you a doubt that maybe this is not a tuple. And then we print the type of x1, we are sure that this is not a tuple, this is of type integer. So for a single value, we cannot create a tuple using this method. We have to do something interesting. Okay, the interesting thing that we have to do is we have to write the parentheses, and along with the single value, we have to end with a comma. Okay, so when you end with a comma, Python understands that this is a tuple. Otherwise, it just interprets it to be an integer. Okay, so when you write 5 comma, this becomes a tuple. Print t2 is tuple here. When you write print type of t2, you can see that it is an object of the class tuple. Let's go ahead. We saw that tuples are immutable. Let's say we have a tuple t1 like this, and we want to update its value. We say t1 of 2 is equal to 4. That is, we are trying to say 0, 1, 2. We are trying to update this value 2 to a value 4. And when we try to do that, we get a type error. The type error is tuple object does not support item assignment. That means we cannot assign new values to a tuple. That means that they are immutable in nature. Okay, they cannot be modified. We can also see that tuple elements can be accessed by indexing and slicing methods. So the same methods that we used for in lists, we can use here. So maybe we can use this as a quiz. Can you quickly try to answer these questions? So when we say T2 of 2, what is the answer that we'll get? Okay, you're right. This answer will be 2. What will be T2 of minus 1? For the answer to T2 of minus 1 will be 9. You're right. What will be T2 of 2 to 5? 2, 6, 7. That's right. We will get 2, 6, and 7. What will be this answer? Colon 2. Just 1 second. No, colon 2 will not. Okay, colon 2 will be 5, 4. That's right. 5, 4. And 2 colon will be 2, 6, 7, 8, and 9. Okay. Great. So I'm happy that you guys are catching up. So let's see, have we done right? Oh, I missed this one question. Sorry. Oh, no, I missed the other question. This is the answer for this guy. And for this one, it should be 2 to 5 with gaps of 2. That is 0, 1, 2. 2 will be 2. We'll skip 1, go to the next one, 2, 7. Okay. Excellent. I think we have done rightly. Let's go ahead. We can also have something called as nested tuples. And nested tuples are basically where within elements of a tuple, I have another tuple. So again, tuples like this, we are not limited to just one item. So here we have an integer, here we have a string, we have a float, we have an integer, and the next element we have is a tuple. Okay. So when we write same like list, when we can write the in operator for a for loop. So we write for I in T1, we are printing two things. We are printing I and we are printing the type of I. Okay. So it will take individual elements. So it will say 2 whose type is integer, B whose type is string, 3.2 whose type is float, 10 whose type is integer, and then this part which is 4.2 whose type is tuple. Okay. So we can see that just like in a list, we can run a for loop using tuples as well. Okay, now this is probably the most interesting thing that I like about tuples is tuple unpacking. Okay, so let me show you what that means. Here we are having a tuple T1 and there are 5 elements in T1. Element 1, 2, 3, 4, 5. There are 5 elements in T1. What I can do is I can unpack this tuple using something like this. I'm writing variables I1, I2, I3, I4, I5. And you see, I'm writing them using commas. I1, comma, I2, comma, I3, comma, I4, comma, I5 is equal to T1. And what will happen is the individual elements of T1 is a tuple. Okay, the individual elements of T1 will be unpacked into this I1, I2, I3, I5. So the value 2 will go into I1, B will go into I2, 3.2 will go into I3, 10 will go into I4, and this tuple 4, 2 will go into I5. When we print 1, 2, 3, 4, 5, we can see our assumption is right. Now we see that I5 is already a tuple. Okay, so I5 has a value 4, 2. I can further unpack it into two variables, I6 and I7. Okay, I6 will take the first value 4, I7 will take the next value 2. So this is an interesting case of tuple unpacking. Okay. Now, why this is useful? Okay, so of course here we can just do one line, but the reason that I find this very useful is because when I have a list of tuples, I can use that in a for loop. Okay, so let me show you an example. T1 is, okay, can you tell me what is the data type of T1? Is T1 a tuple or T1 a list? Okay, excellent. You got it right. T1 is a list, and we know T1 is a list because we see an open square bracket and we see a closed square bracket. And you look at the elements of this list. Can you tell me how many elements T1 has? 4, you're right. We have 1, 2, 3, and 4 elements. And all the 4 elements are tuples, and each of these tuples have 2 elements each. Okay, so that is the structure of T1. when I write something like this, for x comma y in T1, okay. So you remember what happens in a list? If I wrote something like this, for I in T1, T1 is a list, I will take elements of the list. Okay, it will take 2, 3, it will take 4, 5, it will take 6, 7, it will take 8, 9. These are the 4 times it will take values. But when you write something like this, x comma y in T1, we are doing 2 steps. We are iterating through the list. Additionally, we are unpacking the tuple as well. So for the first time, you will get 2, 3. And since we write 2 variables here, the first value 2 will go into x, the next value 3 will go into y. So we can do tuple unpacking and iterating through a list with just one statement. Thus, by printing individually x and y, we can print the individual characters 2, 3, 4, 5, 6, 7, 8, 9 at the different iterations of this list. Okay, so this is interesting. Now, this idea only works if T1 is a list of tuples. Okay, if T1 is a list of tuples of the same type, only then this idea works out. Otherwise, when we write something like this, when we write for x, y in 2, 3, that is, we're just passing one tuple. This is not a list. This is just a tuple with 2 values. And when you write x, y, this will give you an error saying that type int object is not iterable. Okay. So if you want it to be an iterable, you have to put it into a list of tuples. Okay. There is an example of swapping 2 numbers. Let's say I have 2 numbers that I want to swap. I'm saying write a program for swapping 2 numbers. A is having 10, B is having 20. So when you print A and B, you can see that A has the value 10, B has the value 20. Now by swapping, what I mean is B should have the value of A, which is 10, and A should have the value of B, which is 20. Okay. So in other programs like Python, so like C, we would have to write some temporary variable which will be able to help us to swap. Within Python, the task is much simpler. I can write something like this. I can write A comma B is equal to B comma A. That's it. A comma B is equal to B comma A. What will happen is this value of B will go into A, this value of A will go into B, and we would have swapped these numbers. So when we write print A comma B, you can see that the value of A has become 20 and the value of B has become 10. Okay, a very simple Pythonic way of swapping 2 numbers. Let's look at this. Write a program to concatenate 2 tuples. So here we have a tuple A having the values 10, 20, 30. We have a tuple B having the values 20, 40, 50. And when we write C is equal to A plus B, just like lists, we don't get addition of tuples. In fact, we get concatenation of tuples, the joining of tuples. So we get the first value 10, 20, 30. We join it with 20, 40, 50. And then we store it to a new tuple called as C. So with that, we have finished tuples. We have 2 more data types, sets and dictionaries. Let's continue this in the next class. We are already around 10 o'clock. I don't want to continue. I don't want to leave the topic halfway. Let's do it tomorrow. Okay. So let me stop sharing. Okay, Nirja ma'am, I'm done with the class. Okay. Are you there, ma'am?
Can I close the session now, sir?
Yes, yes. I will exit now. And,
okay.
Okay. Thank you so much. Bye-bye.